Hopefully you can see my paper. Today we're going to title this Systems. We're going to be looking at what I'm going to call special cases. It's kind of some special things that you might see when you're trying to work with multiple equations. We have ways to solve them. We can graph, we can use substitution. That's what we're going to rely on today, our methods for solving. But sometimes as you go through and solve them, you're going to see something like special happen. And so we need to figure out what that means. I'm going to show you some with your graphing calculator, and then Mrs. Flood's going to show you some using a substitution method. So let's start by numbering these. We're going to do example 1. And let's say we had this system. Let's say we had y equals 12x plus 5. And then let's say we had 2y equals 24x plus 10. Now, we always do a notice and wonder. One thing I notice about these is that this one's in slope-intercept form. This one almost is. I notice this one's ready for substitution. I could take the 12x plus 5 and substitute it in right there. Anything else we notice or wonder about these? And since I have two equations, I'm trying to solve them. I'm trying to find out if they meet, okay? And we're going to try the graphing method, but we're going to have our graphing calculators help us. So here's what you're going to do. And sometimes it's tough to keep up as like we're trying to use the calculators. If at any time you kind of get lost, just remember the video will be posted on YouTube and on our Schoology page. So if you need to go back and watch how to do the calculator part, it'll be on there for you. Okay. So I have an 83 plus. This is an older version. It works the same though as like your 84s or some of the other ones you guys have too. First thing you want to do is you want to turn it on. Down here in the bottom is the on button. So on. My batteries are low, but they'll last. They should last a while longer. I pressed clear to get rid of that message. And then somewhere on your calculator, you should have this button. It says y equals. This, if I press this, it comes up with a screen that looks like that. And this is a place where you can enter in a whole bunch of equations. And I have room for 7. And so what I'm going to do is I'm going to put my first equation in there, the 12x plus 5. So I'm going to type 12. And for my x, there's a couple ways I can do it. But the easiest way, I think, is to hit this button right here. If you can't find the y equals, let me know what kind of calculator you have. It might be in a different spot. On the 83s and the 84s, they all should be kind of like right around here. Really? It's not there? Let me search it real quick. Oh, found it? Okay, cool. Yeah, so I pressed y equals, and now I'm starting to type in 12. And then this button right here, if you notice, there's a whole bunch of letters with it, or a whole bunch of like symbols. If you press it once, it gives you an x. And then I'm going to type plus 5. Okay? These equations, or these calculators, are all set up for slope-intercept equations. So this one was nice. It was already slope-intercept form. All I had to do was type it in. And if you go over here now and I click graph, it's thinking and it graphed it for me. You can kind of see the line right there. It's a really steep line. And sometimes you have to mess around with and play with the zoom. Like you can try clicking zoom and you can do like zoom in or zoom out. I might want to do zoom in. Now, if you're going to choose one of these, I let it know which one I want to do, like zoom in. So I'm going to press enter. But it hasn't done anything yet. I have to press enter again because it's asking me where do I want to zoom in. Right now it's saying it's going to zoom in at 0, 0. So it's like right here is where it's going to zoom in. And so I have to hit enter one more time. It's thinking, and there it zoomed in a little bit. Okay. So this can help you save time with graphing. Now, we have two equations we need to graph. This one, though, isn't in slope-intercept form, so I actually need to change it before I can graph it with my calculator. And how do I get into slope-intercept form? Well, I need to get rid of this 2. Since it's multiplying by 2, I'm going to divide this side by 2, and this is important. I need to divide everything over here by 2. You don't get to pick and choose what gets divided. If you're changing the equation, you have to do it to everything on the other side. So what do I get? I get y equals 12x plus 5. Wait a minute, I've seen that before. These two are the same, right? If we were to graph it on the calculator, you're not even gonna notice a difference. The graph would kind of look like this. Here is my coordinate plane. The first one was like, it was really steep, right? It like went up like this. Oh, that's crooked, but something like that, right? If I graph this one, it's just gonna be the same line. These lines are like on top of each other. So this is what we call an infinite solutions. Every possible answer would work because it's the same line. I can tell that because they have the same slope, they have the same y-intercept. If we graphed them, it would just be one line on top of the other. Questions, comments, concerns, wonderings? Okay. Keep your calculator handy. We'll go back and we'll do it again for another example later on. But Mrs. Flood, do you want to lead us through example 2? Maybe a way to not use a calculator?
Sure.
Okay. Let me stop sharing my screen. And so Ms. Flood's going to show us another method.
Okay, so I'm going to use a couple of different equations. The first one I'm going to use is y equals x plus 1, right? And we can see this one's already in our standard slope-intercept form. Sorry, in slope-intercept form, not standard. And the other one is 2x minus 2y equals -2. And that is in standard form. So you could take several approaches here. Conveniently, our very first equation here is already solved for y. So that's a pretty short way of saying, well, if I know what y is, I don't have to manipulate this first equation in any way. I can just directly substitute my y here into my second equation for my y here. Okay, so we can then rewrite it 2x minus 2. And now remember, when we use parentheses, we have to put everything in there that y is equal to. So it's the whole x plus 1. And all of that equals -2. So as Mr. Warhol mentioned earlier, the key thing to remember is you have to distribute the entire coefficient here. So it's got to be the -2, not just the 2. So we're going to distribute that to both of our terms inside. We end up with a -2 or 2x minus 2x minus 2 equals -2. So let's just take a moment there and take a look at that. And there's something kind of odd that's happening here. Right, so right here, we have a -2x minus a 2x. So really, our entire term here is going to go away. Both these terms are going to go away. We're going to lose our variable entirely. That's going to become a 0. And we're left with an equation that simply says that -2 equals -2. Now, sometimes in math, teachers like you to get to a final solution where we would have 0 equals 0. And you could do that here by adding 2 to each side. But you can already see the intent that this is inherently a true statement. -2 always equals -2. And this is another case where we have an infinite number of solutions, just like the graph that Mr. Warhol just showed you. And the reason why is any X value that I put right here will work. Right? If I set X here equal to 1, it still goes to 0. I set it to 10, it would still go to 0. And any number I put in here, I will still get a true statement here that -2 equals -2. So this is inherently a true statement, which is what we call it in math. And just for the sake of argument, I'll point out that if we had taken this and had been given it or had solved it for X instead of Y and had input an X here and substituted it, you would have come to the same conclusion. It doesn't matter whether you start with the X or the Y here and substitute it, you'll still end up with a true statement at the end where constant is equal to the same constant. You could also say, so infinite solutions is how we would normally say this. Another possible way to say this is you can say that all real numbers would work. So you could really choose either of these. And there's a special character that we use, a special symbol for all real numbers. And maybe we'll worry about that later. But for right now, you could say infinite solutions or all real numbers. Either of those will work.
And your book loves to use all real numbers. So you'll see that come up. But what does that mean? It means infinite solutions, like Mrs. Flood said.
And one of the things to keep in mind here as well is if you look, and this kind of goes back to what Mr. Warhol was just saying, if we look back up at our equation right here, and if I took this equation down here, the second one, I could turn it into the first one. And I just like to show you that once so you can see that I'm not just making that up. So if we have 2x minus 2x equals -2, we can turn it into our equation 1. So if we subtract 2x from each side, we're going to end up with -2 equals -2x minus 2. And if we divide both sides by -2, we end up with y equals x plus 1. And just like in Mr. Warhol's example, these equations here, the first one we got and this transformed second one, are exactly the same. And so that's why, again, why you have an infinite number of solutions.
Awesome.
Anybody have any questions or comments on that?
Why don't I share my notes? I copied down yours, Mrs. Flood's, along with mine so that we can look at them both together here. All right, so you have two ways to solve a special case. You can use the graphing method, and you will find infinite solutions. Or you can use the substitution method and also find infinite solutions. Just remember, it's also called all real numbers. Okay? Any questions about either of those? And Cooper, there you go. This is the one we used at the beginning. And this is the one for that second example. Okay, so it comes up sometimes. You don't see it very often, but yeah, sometimes you find these, okay? And then we're gonna take a look at a couple more examples, and then we'll do a Padlet and some homework, okay? So, and today, your purpose today is to be able to identify and solve special cases along with the normal systems that we've already been doing. The cool thing is, though, you get to choose your method today. If you like graphing, you can use graphing. If you like substitution, you can use substitution. It's your choice. And of course, you can use calculators if you want. Okay? So let's take a look at another one. We'll call this example 3. Let's say we had y equals negative x plus 11.5. And we had 5x plus 10y equals 55. Now, I notice that they're in different forms. I wonder what the solution might be. And I'm going to try using the graphing method for this, okay? But I'll use my calculator to help me. So if you're doing your calculator, we go back here again. Oops, let me not cover that up. There we go. So my calculator turned off, so I need to turn it back on. And I clear my screen. It's better if it's over here. Yeah, there we go. I go to y equals, and I don't want to use that equation anymore. So what I can do is I can just click clear, and then that'll erase it. So I want to make sure all this is erased since empty for my next problem here. Now, I need to type in the negative x, and this is a very important step. You can't use the minus sign. I know that in math, like they mean the same thing, but on the calculator, this is an operation where the negative is just telling you what kind of number you're dealing with. And so the way you find the negative is, let's see, where is it? It's towards the bottom, I think. Yeah, it's down here. If I press this first, it'll give me a negative. And then the x, remember, is this right here. So negative x plus 11.5. Okay. And then if I graph it, we'll see how it looks. Ooh, I don't see anything. It's because I'm zoomed in too much. So I need to change my zoom settings. Again, I hit zoom here. And then I want to zoom out, which is option 3. So I can just hit 3, or I can scroll down to it. And then I have to tell it where to zoom out. So if I just hit enter one more time, it'll zoom out for me. Oh, there's my line. Look at that. Negative slope. And I can even maybe zoom out one more time. Down and to the right. Okay, cool. This one, it won't graph the way it is. I need to change it to slope-intercept form. So that's one of the downsides of using this method, is this one might be faster just to do Mrs. Flood's method, but I'll show you the graphing. So I subtract 5x. That gives me 10y equals, and I want to put this first because it's my slope, negative 5x plus 55. And then we just have to divide everything by 10. And everything on the right side by 10. So y equals negative 5 over 10, that's negative a half, x, 55 divided by 10 would be 5.5. So this is the equation I'm going to type into my problem here. You know what? I made a mistake. I gave you guys the wrong problem. Oops. Sorry about that. This first period, you get to see all the mistakes. This was supposed to be a 10x. Oops. 10x, 10x, minus 10x. I thought that looked a little weird. Sorry about that. When we divide them, you get negative 1. There we go. Much better. So I'm going to type this now into my calculator. I go back to y equals. And I need to make sure I go down using just the arrow key here, go down to my second line. And what I want to graph negative 1x, or I could just say x, plus 5.5. Okay, and remember, I get back to my graph by clicking graph, and check out what it did. Ooh, fancy. These lines are going to go side by side forever. These are what we call parallel lines. The graph ended up looking like this. Here's my coordinate plane. And then there is one line kind of going like this, and the other line going like this. So they're parallel lines. It means they're never going to meet. There's never an ordered pair that's going to solve both of these problems. So this would be a no solution. There is no answer that'll work. Why is it no solution? Because they are parallel lines. Questions, comments, concerns, wonderings? Okay. Mrs. Flood is going to do example 4 for us, and she's going to show us another method that you might want to use. And then we'll do a Padlet and we'll kind of see how you're feeling. Okay. All right.
Okay, so we're going to work on problem number 4. And for this one, the first equation we're going to look at is x plus 2y equals 23. And then our second equation is 5x plus 10y equals 55. Now, neither of these is already solved for a given variable, but probably the easiest one to tackle would be this x, because it doesn't have any coefficients. And so with one step, we can isolate our x variable and use it for substitution. So if we start with this, and I'm going to rewrite it down here. So x plus 2y equals 23. We'll need to subtract that 2y and put it on the other side so we can isolate our x. And we're left with x on one side and 23 minus 2y goes on the other side. So now we have something that we can substitute into our second equation right here, because we can put it in place of our x here. And hopefully you recall that it doesn't matter which one you solve for first. It doesn't matter which one you substitute, you'll still come to the same place in the end. So substituting this now. Sorry, let me substitute that there. So parenthesis then, 23 minus 2y plus 10y equals 55. So we're distributing our 5, which is a positive 5. And the math here is a little ugly maybe to do in your head. Maybe use your calculator, which is totally fine. You're in algebra, you get to use your calculator. You could also say, well, I know 5 times 20 is 100 and 5 times 3 is 15 and get to 115. But if you feel more comfortable using your calculator, go right ahead. And then 5 times negative 2 is negative 10y plus 10y equals 55. Now here again, we have this sort of odd thing that happens. Right here, we have a negative 10y and a positive 10y. And when you combine like terms here, it goes to 0. But this case is a little different from the last one, right? So the last one, you were left with negative 2 equals negative 2. But on this one, you're left with 115, because that's what we have left over here, equals 55. Well, we know that's not true. That is inherently a false statement. So I'm going to put a slash through our equal sign. And that's generally how we indicate something is not equal, right? Because 115 is not equal to 55. And in this case, we would say that no y value that we put in right here will work. Right? It doesn't matter if you make y 5 or 20 or 45. You'll never be able to put a y value in here that can make this statement true, because it'll always go away and you'll be left just with these two constants, which are not equal. So this is a case where we say we have no solution. And it would be pretty ugly to try and solve this the other way, to do it for the y instead of the x, but you would end up with the same result. Now, these two numbers would be different, but they still would not be equal numbers. So even if you solve for and substitute y, you just end up with a different pair of unequal constants.
That's a really important thing Ms. Flood just said there. When you get to the end, what matters is not what numbers are on both sides. What matters is that it's not true, where she put the slash through. Whenever you get something that's not true, it's no solution. And that's why her answer there is no solution. Her answer is not the 115 does not equal 55. That leads her to the solution, which is none, no solution.
And if we went back and took these two equations, you would find what Mr. Warhol showed on his last problem, which is that these two lines are actually parallel lines. And I'm not going to have you guys do all the work for it, but I will show you that if you did this, you would end up with, and I'm just going to give you the final result because I know you guys know how to convert equations from one form to another, but the two equations you would end up with, one of them would end up y equals 1/2 x plus 11.5, and the other one would end up with y equals, I apologize, that would be a negative 1/2 x, negative 1/2 x plus 5.5. And so if you graph those like Mr. Warhol did, you would find that they have the exact same slope. So they have to be parallel lines, and they have different y-intercepts. So they can't be the same line, right? So in our last one, it was the same slope and the same intercept. This is the same slope, but different intercepts. And so that means that these are parallel.